All right, hello and welcome everyone to the first VIOS seminar of the spring semester. We're excited to have Dan Ershov with a paper on algorithmic collusion in retail gasoline with a discussion by David Byrne. The format is a little bit different than what you might remember. It is meant to encourage more interaction among us. And so here is how it goes. We still have 45 minutes for the speaker, 5 minutes for the discussion, and 10 minutes for a general Q&A. However, you are encouraged to keep your cameras on and to ask questions throughout the presentation. How does that work? If you have brief clarification questions, you may address them to Dan at any point. And Dan would also be making a couple of designated stops specifically meant for questions. The only request is that you use the raise hand feature to ask questions so that it will be easier to keep track and manage. But other than that, we're excited and ready to go. So without any further delay, Dan, please go ahead.
Awesome. Thanks a lot. And thanks to everyone on the organizing committee for inviting me to present at this really great seminar series. So yeah, so this is a paper about algorithmic pricing and competition with empirical evidence from German retail gasoline markets. And this is a joint project with Steph Assad and Rob Clark from Queens and Lei Xu from the Bank of Canada. And the first of several disclaimers that I'll make is that the views in this paper do not reflect the views of the Bank of Canada. The second disclaimer I'll make is that when we talk about collusion or tacit collusion, we only think about it in economics terms, and there's no evidence of any illegal activity by any of the market participants that we talk about here. Okay, so let me just get started. So to motivate this project, the motivation for this project is basically like the massive increase in the adoption of so-called artificial intelligence or machine learning-based pricing algorithms by firms in both online and offline markets. And the difference or the novel thing about these new pricing algorithms relative to kind of old school pricing algorithms that use rules and they have to be pre-programmed with responses to different market conditions is that these intelligent algorithms are intelligent in the sense that they autonomously learn how to reach objectives in unknown environments without necessarily a lot of human intervention. So basically, they learn about the mapping from their inputs. So let's say prices to the objectives, let's say profits, without a human programmer having to specify much about the cost structure, the competitive structure, or anything else in the market. And the increasing adoption of these new types of algorithms is leading to concerns in policy circles, which is basically that these algorithms are going to learn that they're going to reach the best objectives, which is basically like something like high profits, by colluding with each other, by setting high prices. And that might even happen without necessarily any sort of explicit communication. They'll just figure it out that if you set a high price and I set a high price, we're going to reach our best objective. Okay. And this is actually something that's been brought up in both by the EU Inception Impact Assessment, which talks about the increased risk for tacit collusions and market featuring algorithm-based technological solutions, and also by the CMA report in the UK, the so-called Furman report, which again discusses the potential for pricing algorithms tacitly coordinating and the need to understand whether and how this is going to happen. And there's actually an extensive theoretical debate on the effects that algorithms have, or these sort of algorithms have in competition. And there's some evidence, including a really nice paper that's forthcoming in the AER by Emilio Calvano and Giacomo Calzolari and a few other authors, and another paper by Timo Klein showing that in some synthetic economic environments using experimental evidence, simple algorithmic tools can actually learn collusive strategies in the sense that they can learn how to punish their competitors for setting prices that are low. Okay, and then there's the evidence isn't fully set. Basically other settings and other ways of using AI, like using AI as a prediction tool, can be either pro or anti-competitive, which some other papers have shown. But in general, there's a few possible mechanisms through which algorithms can influence competition. For example, algorithms basically speed up interactions between market participants, so you can respond to your competitors much faster, which can actually potentially facilitate collusion through faster detection and punishments of deviations from a collusive state. And then you can also imagine a situation where multiple firms are adopting a similar or the same variant of an algorithm, which can result in something like a hub and spoke type arrangement where they're allocating their pricing ability to a third party, to the same third party, which generates some sort of a collusive equilibrium. Okay. And so this is all kind of part of this really vibrant theoretical debate on algorithmic collusion. But then the question still remains, even if algorithmic collusion is possible in theory or is shown to exist in experimental settings and controlled synthetic settings, how real is this risk in the real world, right? And so this is where this paper comes in. So this is the first paper that tried to empirically tackle the question of what is the effect of algorithmic pricing software adoption on competition in real markets. And what we're going to do in this paper is use this really high frequency retail gasoline price data from Germany. And the reason why we picked this industry and this market is because this is a market where algorithmic pricing of the kind that I've discussed in the last couple of slides, basically it seems to have become widely available for adoption in around 2017. And what we're going to do in this paper is look at the effect of adoption on retail margins and prices. So just to kind of give you a sense of how I see this paper and to give you a bit of, maybe to kind of, I don't know, mitigate the expectations from this paper. So I really do think about this paper as a descriptive study, not necessarily in a causal sense, but more in the sense of trying to actually describe what happens in this market when algorithmic pricing software becomes available and firms adopt. So we're not necessarily going to have a formal model of what competition looks like with and without algorithms. We're just going to try to establish a causal link between algorithmic adoption and outcomes like retail margins or prices. Okay, and in and of itself, this is already a very challenging problem. And there's particularly these three sets of challenges that come into trying to understand this kind of causal effect of adoption of algorithms on competition. The first one is that adoption decisions are not actually observed in the data. So pricing algorithms are often very secretive, and pricing technology is very secretive. So we don't actually see when gas stations or firms are actually adopting this new pricing software. The second problem is that even if you observe the adoption decision, adoption is still endogenous in the sense that the decision to adopt a pricing algorithm, a new pricing software, probably depends on a bunch of observable and unobservable things about the agent who's making the adoption decision. And adopting agents are not necessarily the same as non-adopting agents, so you have this concern that the type of agents that are adopts also would have higher or lower margins for prices. Okay, so this is a big barrier in trying to establish this causal link. And then the last concern that you have in trying to establish this effect on competition is that even if you do manage to establish a causal link between adoption and margins or prices, this doesn't necessarily only come through competition. So you can imagine that algorithms also do other things rather than just potentially help firms collude. They can, for example, help firms understand demand much better, or help firms kind of manage wholesale price fluctuations much better. And all those things can also affect prices and margins. Okay, so what we really want to do is also establish the link to competition specifically. And so we try to solve all three of these problems in the paper. And particularly what we do is, I realize my sound is, so hopefully my sound doesn't keep, okay, my sound is okay now. Yeah, so we try to establish solutions to these three problems. So the first one is we use this high frequency price data to try to identify the point at which the pricing strategy of the firms are changing in a way that's consistent with the adoption of algorithmic pricing. And we basically look for structural breaks and markers that are associated with algorithmic pricing to adopt station level adoption. So just to give you an example, it's something like the number of times the firms change their prices per day. So basically, in some cases, we see firms changing their prices per day from 5 times a day to 15 or 15 times a day. Okay. Then once we actually have this measure of adoption, we still have to deal with this endogeneity issue, and we do that by using instrumental variables. And essentially what we have is an IV for station level adoption, where we instrument for station level adoption with the adoption level at the brand level, or the headquarters of the station's brand. And essentially this is based on this idea that there's 2 levels of technology adoption in this market, an adoption level at the brand level and an adoption level at station level. I'll explain this a bit when we get to this point. And then the last thing is we analyze how the impact of adoption basically varies with market structure. So we compare the effects of adoption on monopoly markets versus non-monopoly markets. And we also compare the effects of adoption on in duopoly markets when 1 station adopts versus 2 stations adopt. So we actually can see what happens in a market when an algorithm competes with an algorithm head-to-head versus an algorithm competing with a human head-to-head. Okay, and then to try to get it like a little bit of the mechanisms, even though again we don't have like a formal model of competition here, we look at the timing effect of when the adoption actually causes changes in margins of prices, and we look at some other features of pricing strategy. Okay, and so this is basically the structure of this paper. Okay, and so let me just give you a summary of results. Basically, what do we find? So the first thing that we do is we find that there's a large number of structural breaks that are happening right around the date that AI became widely available for adoption, around the summer of 2017. So this is already very good news for us, because it seems to suggest that what we're using, these metrics that we're using to capture adoption, are actually capturing something to do with the adoption of this technology. And then when we use our instrumental variable strategy, our IV estimates basically show that adoption increases station margins by about 9%, and it increases prices by about 0.6 cents per liter. And so we find this causal link between adoption and prices and margin changes. And then what we do is we show additional evidence suggesting that algorithmic pricing adoption actually softens competition. And specifically, we find that adoption has no effect on the mean margins of monopoly stations. And in duopoly markets, adoption has no effect if only one of the 2 duopolists adopts. But we actually find these very big effects, like 40% increases in margins and about 4 cents per liter increases in prices, when both duopolists in a duopoly market adopt this technology. So again, this suggests that algorithmic pricing software adoption softens this competition. And then in terms of the mechanism or the timing effects, we basically show that we show that the effects kick in about a year after adoption, which suggests that the algorithms are taking time to learn these sort of new strategies that reduce that increase their margins and prices. And then what we find in terms of the mechanism is that basically there's something like a matching strategy that's happening in this market, where basically when you have 2 algorithms competing head-to-head, a price decrease by one player is much more likely to be matched by a price decrease by another player than if you see 2 humans competing head-to-head. And in some sense, that reduces the incentives, so stations basically stop undercutting each other when you have algorithms competing head-to-head. But I'll talk about this a little bit more towards the end. And so those are basically the results. And so now, so this was the introduction. Now I'm going to have these 2 sections where I'm going to describe the background, the institutional background here, and talk a little bit about the data. Then I'll take a quick pause for questions, and then I'll talk more about the methodology that we're going to use in more detail. I'll take another pause, and then I'll show you the results and conclude. And so perhaps actually maybe I'll just take a pause right now if people have questions, and if not, I'll continue towards the background, institutional background and the data. Okay. Yes, Rahul.
Hi, Dan. Just a quick question. Is it surprising that these algorithms are just bad at learning the underlying demand? So should we be surprised that there's no effect whatsoever in the monopoly situation? So I mean, because I guess the results on the previous slides, should I be thinking that the only thing that these algorithms do is learn to collude, and otherwise they're useless?
So that's actually not true. So there is some subtlety in here in the sense that, so what we see is that for the monopolist, there is actually a change that's happening at the 95th percentile of the prices. So at the very edges of the margin and price distribution, there are changes that are happening for the monopolists. And so that suggests that the algorithms are not just, helping these firms collude. They're actually, and especially for the monopolists, there's a decrease in the 95th percentile prices. And so that basically suggests that the monopolists, the human monopolists, were pricing too high. And potentially they didn't pay enough attention to the fluctuations in demand. And so the algorithm is learning that and is reducing their prices. So it's not just about collusion. There's other effects as well. Okay. Great. Okay. Let me lower your hand. And so okay, background. So let me just tell you a little bit more about pricing algorithms and gasoline retail. So first of all, gasoline retail is basically a leader in algorithmic pricing software adoption in the real world. And one of the reasons that they do that is, one, there's plentiful data to kind of train the models. There's also already a history of using deterministic pricing algorithms, like these non-autonomous algorithmic algorithms of prices. And so basically you have this relatively early adoption of this algorithms in gasoline retail. And so there's a bunch of these intermediaries that are proposing this algorithm, that are selling these algorithms to gasoline retailers, and their marketing pitch is very much based in some of these kind of keywords, like about neural networks and deep learning, but also this idea that they can help a station owner or a gasoline retailer with dynamics, with customization, and even in some of their marketing materials with helping to avoid price wars, which is already something that kind of triggered my interest. But if you want to know exactly a little bit more concretely about what's in these, what is actually going on in these sort of pricing algorithms, basically the one algorithm that we have some information about, that's not necessarily the only algorithm in this market, but actually one of the main ones that seem to be active, basically has this model of consumer and gas station interaction. So this is not a competitive model where gas stations are competing with one another. This is not a strategic model. This is just a model where a gas station is optimizing their prices, and they're also considering the consumer behavior. Okay, so there's some sort of a quote-unquote model of consumer behavior and a quote-unquote objective function for the station. And essentially what this algorithm does is that it uses observational data to fit the model, like historical weather, the prices, volume, etc. And these inputs that they're using to fit the model include competitors' prices. Then they're choosing prices for the station to maximize its objective function. Then there's a new realization of the market, both for the station and for the competitors. And then they're basically taking this new realization of the market as new inputs and refitting the model. Okay. And so, so I should mention again that there's still a lot of unknowns in terms of how these algorithms actually work, in terms of their memory, the kind of method that they use to learn, whether it's reinforcement learning or adaptive learning, the horizon in which they're optimizing their prices, which seems to be a longer term horizon. But there's a lot of unknowns here. Even the idea of what is exactly in this model of consumer behavior and what is exactly in the objective function of the station is very unclear. But essentially, this is kind of the schematic form of this algorithm. Yes, Tommaso has a question.
Can you hear me?
Yes.
Yeah. So do you know who makes the decision on the prices? So you are talking about stations. So is it really true that each station is essentially choosing the prices and they are the one that contact this firm providing the algorithm? Do you have any evidence about how this works?
So there's kind of, so the way that we think about this and the way that I think it fits with both the marketing materials and how these so we don't actually have direct evidence on exactly who's making each decision, but we have read, try to read very carefully between the lines of all the marketing materials, and we also have some information on the history of technology adoption in these gasoline retail markets. And basically, it seems like there's kind of two levels of decision making sometimes. So there's a level at kind of the brand headquarters level that wants to kind of adopt this new technology, because it's potentially clearly beneficial for the stations. But then at the same time, there's also a decision that's made by station owners, both in terms of adoption, because essentially, these algorithms are potentially costly to adopt. Like, potentially you have to like upgrade a bunch of things in your gas station to be able to run these sort of these algorithms. But also because, you know, the customization is really at the core of many of these algorithms, and allowing them to kind of fit specifically to the individual stations is a really important selling point of these algorithms. So there's definitely like something very station specific that's happening here. Okay. But we'll talk a little bit more. That also comes into play when we construct our instruments. So I'll explain that a bit more. Okay, and so then, why do we? And so again, like, why do we look at Germany, and why do we look at this at gasoline retail? So basically, there's a few of these big intermediaries that produce these algorithms for sale for different industries. And what we find is that what we found looking at German trade publications, where basically that the algorithmic software became widely available in Germany starting summer 2017. So this Danish company called A2I Systems, basically was advertising in these trade publications saying that it offers these station operators in Germany this highly innovative pricing system as an easy-to-use cloud solution. And then we also know that other companies, so not necessarily this A2I company, other companies that were producing these sort of algorithms were also active in Germany at the time and offering this sort of algorithmic pricing software. So there's a bunch of these. So basically, like 2017 seems to be when this new type of software becomes widely available for adoption, and it becomes widely available for adoption in Germany. And so what data do we have to try to get at this empirically? So we basically, so with apologies to David, I do think that Germany has the world's best gasoline price data through this like market transparency unit for fuels, and I'm not going to try to pronounce the German version here. But essentially, it gives you the full universe, or close to the full universe, of price updates for basically like all gas stations in Germany. And this is basically the raw data that we use. So the raw data that we use are all price updates for 16,000 stations in Germany from 2016 to 2018. And we look at E5 gas, which is the highest market share. And what we do with this data is we compute the daily average price for each station. And then we can also combine this with purchased regional wholesale prices to compute daily margins. Okay. We also observe, something we also observe through this data is the location information of the station. So their zip code, their 5-digit zip code. We also observe the brand of the station, although I should mention that we don't actually observe the relationship between the station and the brand, so whether the station is directly owned by the brand or whether it's a franchisee. And that allows us, and so the location information actually allows us to merge in a really rich set of controls like local demographics and weather at a very granular level. And then what we do with this data is we basically so what I'm going to show you is going to aggregate stuff at the weekly or monthly level. Okay. And so just to tell you a little bit more about the data and how competition looks like in Germany. So basically, again, like what we observe in this data is the brands of the station. And so you basically have this structure where you have a few stations with a few brands with lots of stations. So Shell and Aral are the biggest brands in Germany with about 2,000 stations each. And essentially the top 19 brands account for about 71% of all stations in the markets. And then geographically, these stations are actually fairly close together on average. So on average, you have 3 stations per 5-digit zip code, and an average station has about 1 competitor within 1 kilometer and 5 competitors within 3 kilometers. And something we should note about this market is that in mid-2015, Shell announced this price matching program. It was basically only available, so it wasn't fully available to everyone in this market. It was only available for a subset of the consumers, of Shell loyalty card holding consumers. But there's essentially a few papers that show that the program facilitated collusive behavior and it increased prices very quickly around 2015. And essentially what we're going to do is we're going to take this environment as a given, and we're going to try to see what happens to this existing competitive environment with this price matching program in place once you introduce algorithmic software on top of that. Okay, so I should just note that this is happening. Okay, so let me pause here and see if there's any more questions, and otherwise I can move on to the methodology. Stefan, yes.
Yeah, just quickly, Dan, does it matter that, I don't know if I understood you correctly, that a lot of these stations are adopting the same kind of software? So it's probably different if you have two algorithms running against each other, or literally the identical one.
Yeah.
Do you distinguish between that, and how much is that an issue?
So I agree that, so we don't observe which algorithm the stations are adopting. We can only observe that they're adopting some algorithm through our adoption measures. This is actually very important, I think, in terms of the potential effects. It's something that we can't necessarily get at with this data. And I agree that there would be different effects. It would be a very different, it's a very different story, you know, if two stations are adopting the same algorithm versus different algorithms and learn how to collude. I think it needs, I think there are ways of getting at this with this data, specifically seeing how different stations respond to like specific kind of shocks, but it requires very specific variation in the data to try to identify the separate algorithms. I see. But yeah, so we can talk about this more towards the end. Any other questions?
May I ask a question at this point?
Yeah, of course.
Contrary to many other countries, in Germany, prices started to cycle along each day very strongly. Mm-hmm. I didn't get in at the beginning of your talk. I had problems with Zoom. Did you mention that? Does this play any role in your paper?
So what we do in this paper is we calculate kind of average daily prices that don't necessarily take into account of this like intraday fluctuations. So, I think there's been intraday price fluctuations in Germany since before our software, before this like software became available. So in some sense, we're taking this whole structure, competitive structure and environment in Germany as a given and trying to see what happens if we can identify this additional change that's happening as a result of this new software coming out online, basically.
Dan, Michelle here. I can't get my hand to go up, so I don't know why, but sorry for that. So do you have any information on whether these gas stations are like kind of really, really big rest stops with a restaurant and so on, or whether they're just these small ones that you go to, that might also influence pricing?
Yeah, so we have this really, we have really detailed demographic information about the area around particular stations. So we know like who are the rural stations and who are the urban stations, but we don't have a lot of other information. At some point, I actually collected which stations are in highways. So those are presumably kind of the more sophisticated, like bigger kind of stations. And we honestly didn't get a lot of traction on separately trying to identify the effects on them versus on other ones.
Daniel, could I just quickly, freeways would be very important to distinguish, much more than highways. Highways versus non-highways. Freeways would be absolutely critical. Freeways have kind of a, they have also, by my understanding, they have exclusivity rights and stuff like that. And there is clearly no close competitor and stuff like this, but I would very much opt to do that.
So maybe it's like a language thing, but I basically like collected all I collected all the information about stations that are along I guess freeways or highways, because I don't but maybe yeah. But I point taken. Larry.
Yeah, just following up on Michelle's question, since you know the locations of each of your gasoline stations, you might be able to use Google Maps to tell you more, and the satellite pictures that goes along with Google Maps to give you a picture and tell you, gee, does this look like a small 3 or 4 pump station, or this is a multi-pump station with something that looks like a substantial store as a part of the overall operation. So, turning some research assistants loose on, the Google satellite pictures might really enhance your data in this respect.
No, that's a really good suggestion. Thanks, Larry. I think that's something that we could do with in the future. Okay. Good. So let me just tell you a little bit more about what we do here. So basically, the first thing that we have to do is that we have to identify station level AI adoption, right? And so the idea here that we have is that based on our information about how technology adoption in these markets often happens, in gas and retail markets often happens, is that station owners have some discretion about adopting the software. And the reason is that, and actually, I mean, the reason kind of plugs into what Michelle and Larry were saying is that there's some heterogeneity across different stations. And so, if you're a station in a rural area and you don't have a high-speed internet connection, and you have to like manually change the sign that says what your prices are, you may not want to adapt a software that's going to change your prices like very quickly, right? Because it's just too costly for you. So the way for you to adopt would have to be to like upgrade your point of sale system, to upgrade your pump, and basically do a bunch of these like very costly updates. Other stations, it may be less costly for them, but essentially like there's some sort of like a cost associated, either in terms of like actual upgrading or in terms of learning how to use the software, in terms of adoption here. And so we don't actually observe the adoption decision. And so we have to think about how to identify that. And the way that we identify that is by using our pricing data and looking for changes in markers that are associated with algorithmic pricing. And here, our guidelines basically comes from the promises of the providers, which is fast and responsive prices. And basically some of the previous literature in computer science on these pricing algorithms that are basically saying that these algorithms allow you to price things much more effectively and much faster. And so we're going to capture these features of the promises of fast and responsive prices using 3 measures: the number of daily price changes, so the number of times the station changes the prices per day; the average size of price changes, so how large are the price changes that the station set; and then the response time to rivals price changes. And so here we basically define a rival as the closest station within 1 kilometer radius that belongs to a different brand. And we define the response time as the gap between the price change of station J and the subsequent price change by station I. And so essentially what we're looking for are structural breaks in these measures. Nikita, yes, you have a question?
Yes, hi. So related to this, how should we think about consumers searching for better deals in the light of what you just said? So if we have sort of a faster and more responsive pricing, it wouldn't matter if the consumers weren't able to observe this, at the same frequency in a sense. And so one worry would be that the adoption of these AI technology may somehow, coincide with the adoption of the consumer's search technology, where they can, I don't know, access the prices of the nearby gas stations on their mobile phones and so on and so forth. So
yeah. So that's a really good point, and I think it's come up in some of these other studies of gas and retail, like Fernando Luco's AJ paper. But so I think the nice thing here is that the data that we're getting through this market transparency initiative came online in 2014, and this data is directly fed to consumers. So the idea is that if you're in Germany, you can actually, like, since 2014, you were able to access information through your mobile phone about the prices of all the gas stations that are near you. Okay, so it's not like there's a sudden change, there shouldn't be any sudden changes in consumer search behavior that are happening around this time. And I think there's a few papers that actually show that around the time that this transparency, price transparency measures were introduced, you did actually have a change in the search patterns of consumers. But that hasn't necessarily happened since. So I think we can really isolate the kind of supply side effectively.
Hey, Dan, sorry, my raise hand thing doesn't work as well. When you're looking at rivals, you say different brand. I remember you talked about Shell and Aral and some others, but are these mostly company-owned stations or are they franchise? Because if you and I are both Shell, but we're franchisers, I don't quite care about your profits. Any distinction between rivals that you know are truly rivals or not?
So not in this. So we haven't done that. No, so we actually don't observe this directly in the data, unfortunately. I think there are ways that we can get at this with the high frequency data. So for example, if we see like a bunch of stations changing their prices like frequently at around the same time, this suggests that they're kind of company owned because their pricing is going to be more centralized. So I think there are ways in which we can get at this. We're not doing this right now. But if you're really worried about this kind of rival response type stuff, then
I'm not worried about anything, Dan. I'm too old to be worried.
No, so we were worried. So let's put it this way. So we were worried about the rival response stuff, especially because there are some stations that don't even have rivals. And so one thing that we did was actually like play around with the definition of what defines, an adoption, and we actually just removed this rival response measure and we just focused on the first two measures, and that doesn't qualitatively change our results.
Okay, thank you.
Thanks. Yeah, so we look for structural breaks in these measures. So let me just give you an example of what a structural break looks like. And basically what we see is that, so the red station here, so these are two German stations from where we look at the number of times, the average number of times they change their prices on a weekly basis from the beginning of 2016 to the end of 2019, or to the end of 2018, sorry. And basically what you see is that the red stations basically changing the prices 5 times a day throughout the time period. But then for the blue station, there's a sudden kind of jump around the middle of 2017 where they switch from changing the prices 5 times a day to about 10 to 12 times a day. And so this is basically going to be the kind of change in pricing behavior that our structural breaks measures are going to adopt to identify.
Dan?
Yes, David.
If my rival changes its behavior, isn't it likely that I might change my behavior to match that? So you could have one guy adopting and the other guy just responding to the adoption in a way that will look as if the second guy is adopting as well, even though he is not.
Yeah, so this is also something that we were really worried about. Basically that you would have this like false adoption, right? A false adoption measure. And so basically what we see in the data is that we have lots of this like asymmetric adoption in markets. So lots of times you have one station in a market that's adopting and another station that's not adopting. So it suggests that at least in this data, this is not a particular concern. Okay. I really don't have a lot of time. I just realized what the time is. So let me just very quickly tell you, finish what we do and show you a little bit of results. Because yeah, so right, so what we do with these structural breaks is that we define adoption as essentially a station having a break in at least 2 of the 3 measures within 4 weeks to be labeled as an adopter, because essentially you might have structural breaks in individual adoption measures for many different reasons. And we tried, and again, like as Steve mentioned, there's a lot of concerns here about these specific measures, so we tried a bunch of these different definitions, and the results seem to be robust. And so then the main idea is like, so then what we do with these measures is try to identify the effects of adoption on outcomes. And so we run this regression with kind of station and month fixed effects, a bunch of time varying control, where we try to identify the effect of adoption on outcome Y. And so the main concern here is the endogeneity of this adoption decision, because adoption should be correlated with station specific time varying unobservables. And this correlation should actually attenuate beta towards 0. And we do find a substantial observable heterogeneity between adopters and non-adopters. So again, this is basically like something, adopters are present in denser markets, for example, in more populated markets, have more competitors nearby. So endogeneity should be a big concern here. And so what we need is some sort of an IV. And so we need something. So we decided to use an instrumental variable strategy. We need some sort of an IV that's correlated with station's adoption decision, but not necessarily with station specific unobservables. And so what our proposed IV is using the brand of the station. And so basically what we calculate is the share of station I's brands other stations that adopt AI by time t. And the intuition here is that there's kind of two levels of technology adoption at the brand HQ level and at the station level, where brands are making these big picture decisions that influence individual station owners' adoption costs. And they facilitate and subsidize station adoptions, for example, by providing technical support and maintenance. And we have this really nice example from a past episode of technology adoption, where stations were adopting electronic payment systems like credit cards. And basically in the 90s, we have this nice case study where Exxon decided that this new electronic payments method was really useful, and so they basically decided that they wanted their stations to adopt it, and so they subsidized their stations' adoption with a 10% subsidy. And so this is kind of what we're thinking is going to happen in this adoption decision as well. And so essentially, that's going to be our instrument. We have if you don't like this instrument, we also have an alternative IV, which is basically like using variation in local broadband availability. And the results are consistent. Okay, and so then, what we want to see is what are the effects of the algorithms on competition? Because again, algorithms can affect competition, but they can also influence other margins for other reasons. And so we look at competition in two ways. One of which is comparing the adoption effects in monopoly and non-monopoly markets, and the second one is looking at the market level and duopoly markets. So we compare outcomes for markets where no duopoly is adopted versus one duopoly is adopted versus both duopolies adopted. We essentially run this market level regression. We have a dummy that's equal to 1 if one of the stations adopted, and we have a dummy that's equal to 1 if both stations adopted. And of course, this is also endogenous as hell, so we have to instrument this. Okay, so we have instruments that are based on our station level instruments. Okay, so in the next 4 or so minutes, let me run you through our results. So the first thing that the first thing I want to show you is just the distribution of adoption timing, where what we see is that we have this like large spike in the adoption timing of individual stations that are happening right around the middle of 2017. So this is exactly around the time when the software was becoming available, which seems like really good news in the sense that it seems like we can actually capture the adoption decision, the adoption decision of a station using our structural breaks measures. And then the other thing I also want to show you this geographic map of adoption, where the main thing is basically based on David's question. We observe lots of zip codes where not all stations are adopting at the same time, or not all stations are adopting by the end of the sample, which suggests that we don't have this like false adoption based on responses to competitors who adopt. And then the other thing I want to show you was adoption at the brand level, where there is substantial variation at the brand level adoption. And so basically this suggests that our idea of using the brand as an instrument kind of makes sense, especially because once we do a balancing test at the brand level, we actually don't find that adoption at the brand level is correlated with any brand level observables. Okay, so in some sense, there's some sort of like an idiosyncratic decision at the brand level of when to adopt this technology. Okay, so I have 2 or 3 minutes, so let me get to the results. So first I want to show you the station level results. So the baseline station level results basically show that margins increase by about 0.8 cents per liter, about 9% after adoption. But once you break it up by market structure, you actually find that for ZIP monopolists, you don't have changes in mean margins or mean prices. Whereas for non-monopolists, you have increases in mean margins and mean prices, which suggests that competition is really driving this effect. Now, based on what Rahul was asking, again, we do find some effects for monopolists. We find that their highest prices are coming down, okay? Which again suggests that there's something going on in this market that is not specifically related to this like collusion aspect. That potentially these algorithms are actually also helping you optimize your prices and increase and change your prices in a better way, okay? And we don't find this kind of 95th percentile effect for non-monopoly stations. And then for the duopoly markets, we find that both the margins and the prices are increasing not when one station adopted, but when both stations are adopting. And these increases are actually quite substantial. We basically find a 3.2 cent increase in margins, which is a 40% increase relative to mean market level margins for these duopoly markets. And we find a 4 cent per liter increase in prices, which is also fairly large relative to the average prices here. Okay, So again, the key punchline here is that we don't see any effect when one station adopted relative to no stations, but then when both stations adopt, we see these effects coming in. And then again, I wanted to talk a little bit about kind of, again, we don't have like a formal model here of how to think about human competition in this market and versus algorithmic competition in this market. And one of the reasons for that is that I think there's a lot of uncertainty about how humans compete in gasoline retail markets. And there's a lot of uncertainty about what exactly are these algorithms that different stations are adopting. And so we're not going to try to model this explicitly. We're going to try to look at some evidence to suggest either both learning and the mechanism through which the algorithms are raising the prices. So the first thing that we do is look at the timing of the market of the increases in margins and prices. And basically what the experimental theoretical literature suggests is that if algorithms are learning not to compete, then this should imply that margins are increasing over time. Whereas if algorithms are just bad at incorporating information, that should actually probably increase margins very, very quickly and prices very quickly. And what we find is that there's no immediate effect of adoption for both stations. The adoption effects are kicking in slowly and are really kicking in about 12 months after the adoption by both stations, which suggests that there is this kind of learning effect in this market. And then the other thing is that we try to look at what is actually happening here in terms of pricing strategies once you have these two stations adopting. And we find essentially that that algorithms prevent undercutting, where the price decrease by one duopolis is more likely to be immediately followed by rival decrease after they both adopt. And essentially high-priced duopolists are stopping trying to undercut their low-priced rivals. Okay, so this is what's happening in this market. So there's kind of more stability in the price in the price level of the two stations. And then, yeah, so we have lots of robustness checks that are useful to kind of assuage various concerns. And so let me just in the last minute or so summarize and talk a little bit about the policy implications of what I think we find here. So just to summarize what we do, we use data from German gasoline retail markets to look at the effects of algorithmic pricing adoption on competition. And we show that AI adopter margins increase after adoption, where mean margins in duopoly markets increase only after both duopolists adopt. And this is happening only a year after both are adopting. So this suggests that there's learning, and it coincides with changes in other pricing strategies, which overall seems to suggest that algorithmic pricing adoption has an effect on competition, okay, in the real world. And so there's a bunch of policy questions that kind of come out of this. And I'll kind of leave you with some of these, and perhaps we can talk about these more in the Q&A section, which is basically like, one is, should algorithmic pricing cause us to rethink our treatment of collusion, where instead of focusing on communication, we can try to look at pricing rules that are used by different algorithms? The second one is, should algorithmic pricing cause us to rethink price transparency? So again, price transparency seems to be really important for training these algorithms and for algorithms getting information about the behavior of their rivals. That's important for their functioning. The third thing is again, like, we don't actually know using this data what specific software the different players are using. And again, as Stefan mentioned, there's very different implications for the same, whether the two competitors are using the same software versus different softwares and getting the same kind of outcomes. So our recommendation or suggestion is that antitrust authorities should really conduct a software census in some of these markets. And then the last thing is basically like our antitrust authorities focusing on the wrong thing, in the sense there's a lot of effort going towards prosecuting and finding this like hardcore cartels, whereas potentially like some of these other measures, some of these other things can potentially reduce prices and margins at a market-wide level in ways that prosecuting a single cartel may not. Okay, so I'll stop here. This is a legal disclaimer, how this is all about economics. And so let me just stop here and give David some time to discuss.
All right. Thank you so much, Dan. And we now have David with a discussion for 5 minutes. Please go ahead.
Thanks, guys. Just a sec. Okay. Good morning from Melbourne. Just a real pleasure to be able to discuss a really great paper from Dan, co-authors. The headline result, just to quickly, I think it's pretty clear, but basically this finding from the field that we'll find margin enhancing effects of algorithmic pricing, only when the retailers have both adopted. The way I read the paper really is it's a sort of a field-based validation of a lot of the concerns Calvano et al. Raised in their recently published AER paper. But I think when you work with the antitrust authorities in practice, you quickly learn they put a lot of weight on things happening in the field. So the lab kind of tees it up, and then these guys are kind of following it up with, yeah, we found this. And I think some of my comments, to the papers, trying to push what the field can bias beyond what we've learned from the lab. So, I think one thing is, it was already alluded to, we have these super high frequency price cycles in Germany. Most places in the world have monthly or weekly cycles. In Germany, you get these sort of cycles that start high in the morning, the firms undercut through the day, and then they raise the price the next day. And I think that it's the curse, it's kind of the blessing and the curse of having real-time price data. These kind of intraday dynamics can be studied in this paper. And I think it's, for a paper that's focusing on speed and coordination of price adjustments, and if AP is all about speed and adjustments, as we're saying, I think it's, I actually think there's probably part of the story is about the evolution of the cycles themselves. So what they're getting on undercutting and increasing prices reflects probably things that are changing during the undercutting and relenting phase of an Edgeworth cycle. So I think unpacking that is probably going to be important for really trying to uncover what AP is doing, and we're saying we're taking cycles as given. It's not clear, maybe do the algorithms think price cycles are good for profits, or do they destroy the cycles? Where do they destroy the cycles? So there's a lot of sort of questions there. In a sense, I feel like you're leaving money on the table, and you can kind of focus the microscope even further in with the data you have around the breaks with the AP. So that's kind of one gasoline kind of comment. Another one is, again, so being in Australia with not many markets, it's kind of jealous looking at somebody who's studying Germany with lots of people and lots of markets. Makes me wonder a couple of things. One is, do the algorithms sort of respond differentially to markets, differentially based on sort of things like income, local income, fuel type, things that kind of might be correlated with demand elasticity? I'm trying to figure out, what are the inputs into these algorithms? Do they price based on local factors? Or should I think about AP adoption and its impacts over time reflecting the aggregation of information across all of Germany? Maybe in market A, they're learning from things that are happening in market B, and that's influencing the pricing decisions in A, or maybe it's just one big aggregation. So there's a question of whether or not they're learning across markets, or is everything really, really within market? They condition on things that are happening within the market, things like income we might think of. And I think, again, I think this pushes it beyond, even further beyond what the lab can bias. And I think then it starts bringing up even more, more important, or more, they already have a bunch of important policy questions here. There's more that can kind of start coming up, like distribution concerns. Do richer or poorer areas do worse under algorithmic pricing? As we understand these inputs, we're going to understand a lot more sort of the implications that these have for not just competition, but sort of distributional issues. So I think there's more you can basically do. I think, Dan, over time, both on the cross section and over time with this great data set. The last thing just I'll raise, and just to kind of prompt discussion, actually, I started studying retail gasoline 10, 11 years ago, working on a price fixing case. And I remember working with the company, and I got a sense of the algorithms that they were using, or it wasn't artificial intelligence, but it was sort of these, a bunch of data would go into something and some machine would spit out a number. And I was just out of grad school doing structural methods, and I realized all this structural IO stuff's just trying to reverse engineer algorithms. So it's kind of deflating at the time. And I guess I'm wondering what we're going to do forward with going forward with this, thinking about this testing or assuming supply side of structural oligopoly models to try to understand competing algorithms. If we know it's just about algorithms, like, what do we need to do empirically now? Do we have to invert price dynamics to try to figure out what these algorithms look like? Because I think if we're going to credibly inform policy, we need to be able to say things about what these algorithms actually do, and we need to be able to back out where and when they're happening, like they're doing in this paper. And I think Dan alluded to it. I think a challenge, if we can identify algorithms, if we can continue to find that they're giving rise to super competitive prices, there's a bunch of policy questions. We've already talked about what's communication. do we need to regulate the code? The thing is this is going to be a legal mess coming down the pike as we see more papers like Dan's, coming out. And I don't know. I mean, maybe at that point, that's where the economists we check out and say it's too hard. But yeah, so these are sort of the questions as IO economists. What are we really identifying with conduct, and really do we need computer scientists and engineers, not us, in studying these types of markets? So that's it from me. But yeah, again, thanks a lot for having me in to discuss a really great paper. Put it on your PhD syllabuses because your students will love it and they'll all want to become IO economists. Thanks.
All right, thank you so much, David. And yeah, let's go to our open Q&A session, please.
I guess Luis, I think, was first, and then Steve, and then Ro.
Okay, before, if I may, I have a small survey suggestion, which would be to use the chat room, which I think is highly productive and efficient in these sort of seminars, but that's just a suggestion. Anyway, one thing that the results seem to clearly suggest in here is that it takes two, or at least two firms to tango, both in terms of learning how not to increase prices and to actually not to increase prices. And so this suggests a very natural sort of dynamic model. And one possible identification strategy for that is to compare areas when there's only one gas station, areas when there are clearly two gas stations, and areas when there's more than two. And I would have expected different patterns of take up of AI, controlled from everything else. I don't know, this is also related to what David Janisov asked earlier. I don't know if this is something that you think you could do with what we have.
So just really quickly, so we do that. We do look at monopoly markets and then duopoly markets, where we do find these like differential effects in these different types of markets. But I agree that there's more scope. Sorry. But I totally agree there is more scope to look at markets with more than two competitors and see what happens when kind of there's different shares of the competitors are picking up this software. Thank you. Sorry.
Hey Dan. First, I was going to complain about waking up at 6:30 in the morning, but David, man, he really takes the cake on this one. So thanks, David. There were three things that came to mind. One, I'm just kind of thinking about the magnitude. You said about a 4-cent increase in prices. I think the price of this was for a liter, right? So I think it's about $1.50 a liter. So we're talking about a, slightly under 3% price increase after a year. I'm just wondering if you think that's meaningful or not. Obviously, for profit margins, it could be quite meaningful. But that was one thing. The second thing that I was wondering, and this dovetails on Luis's point, in Emilio's really cool paper that you mentioned, the more firms there are, the harder it is to learn and compete. So I wonder if you could actually look at that and see the extent to which that's true. And then last but not least, since this is a topic that I thought a bunch, maybe 2-3 years ago, and then I kind of moved on to other things, and now you whet my appetite again. So this seems like a very best case scenario market for algorithmic pricing. Simple product, no entry or almost no entry and exit, and changes to market structure at the local and even broader levels. Whereas if I think of other online retail, where there are thousands, tens, hundreds of thousands of products per retailer or marketplace, with entry and exit that kind of changes who your competitors are, and how much we could generalize from this to the markets where I think the regulators are a lot more vocal about. So just curious.
Larry? Yeah, so I think with the decision by the organizers to take questions from Larry and Rahul and then conclude, and then I think we can talk after the seminar as well.
Okay, I just want to follow up on a couple of things that before they start skipping out of my head. Following up on something that David Byrne said, should we start in an antitrust sense, thinking of these software purveyors as sort of the hub of a hub and spokes semi-conspiracy, if you like, and the software itself as a facilitating device. Both of these, pieces of terminology familiar to antitrust enforcers, lawyers. I think we'll get it pretty quickly. Following up on the other David's point, David Genisov, if you can't really tell when somebody has adopted, then your identification of, you see two firms in the market and they're both changing their frequency, you still can't tell, was that one adoption and just a good guy, a guy who stays up late and is, spending a lot of time matching the guy across the street. So I think you need to be a little more careful about this identification question. Last, I didn't see the details on the regressions, but at the beginning, you talked about using weekly data. And I'm wondering, you have all these daily data. Are you throwing away information, sort of picking up on something that both Luis and David Byrne said? Are you throwing away information by consolidating into weekly? Why not stay with daily? And that gives you a lot more opportunity also to sort of slice and dice your data and be really doing chow test like separations of you can't use F test type separations to see are dummy variables just sufficient to be capturing the differences, or are there really differences in behavior that you can only capture with separate regressions for separate subsamples, and then using a blind or Oaxaca decomposition to try to figure out the net effects of what's going on.
Rahul, please.
Okay, yeah, I mean, we're running over, so apologies for running over. Also, because I'm just gonna re-ask a different version of my original question. So I guess where I'm coming from is that I'm a little curious about the interpretation of your results, because the measure that you're using to identify adoption is frequent price changes. So even the monopolists who are the only guys getting these algorithmic prices are moving prices around a lot. And so it's a little weird so maybe it's not weird, right? So maybe what's happening is that, I'm adjusting prices in the morning when there's a lot of demand, I'm moving prices up, and then, people maybe are less elastic, and then I'm moving it down in the afternoon. And so on average, my price is not changing, but I am still adjusting the price to basically like very micro demand conditions. And so it's entirely possible that the measure that you're using for collusion, which is the average markup, is not a good measure of welfare at all. And so it's entirely possible that even though average markup is higher in the market with competition, that consumers are actually better off relative to, let's say, what's happening in the monopoly, because it really depends on demand elasticities over the course of the day.
Okay, thanks. Dan, would you like to very briefly just pick up on some of these and then we'll finish up?
Yeah, so these are all super great comments. Okay, let me just start with Steve. So the question is like, this is a best case scenario for algorithmic pricing. What is happening in a more complex market? For sure, our results suggest that, it's not obvious how if you can like fully generalize from this, but the fact that we do see something happening in this particular market, and there was a lot of skepticism about whether or not this could even be like held up in practice. And so our results suggest that this is the case. Of course, in more complicated markets with entry and exit and with like all of these like product heterogeneity, it's much more complicated. So it's not necessarily something that is likely to happen in other markets, but it's something that we should be concerned about. Okay. And then this idea of whether the more firms there are, the harder it is to compete and to coordinate, the answer is yes, because that's basically what the results suggest, because we find these really big effects for the duopoly markets. But then when we look at the average adopting stations in a non-monopoly market, we get much smaller effects, which suggests that the biggest effects are coming from this duopoly station, which suggests that, which is exactly kind of what some of the experimental papers were showing. Then for David, yeah, like David's questions are super great, and kind of dovetail with some of the stuff that Rahul was saying, in the sense of thinking of, and Larry too, in the sense of thinking, you know, we really took this like 30,000 kind of feet view of prices, where we look at average prices in a day that are averaged over a month. And of course, there's like a lot of scale with these pricing algorithms for like intraday price discrimination. And we did start looking at like kind of higher speed effects, and these mechanisms that are operating like within the day. And this is some of the things that we're finding, that, you know, like these algorithms are trying to, in some sense, kind of break the Edgeworth cycles, where they're more likely to respond to price reductions, and so they're stopping this like undercutting behavior that is happening in these markets. And this is actually even consistent with some of the marketing and some of the, not the marketing, but their kind of marketing materials, where they're saying that this is going to help us price dynamically better over time and avoid Edgeworth cycles even. And so let me, so let me just stop here, and thank you all for the really great questions and discussion.
Okay, so just to clarify something, we are going to leave this room open if you still want to chat a little bit more with Dan. But thank you all, Dan, David, and all of you, for a wonderful interaction. We wanted more interaction and we got it. We also went over time. That's probably on me. Sorry about that. Thank you, everyone, and see you again next week.